Good afternoon, and welcome to this session. And the talk is about running Mesos and Marathon on ARM servers. ARM has great success on mobile market in the last several years. Now we are beginning to get involved in enterprise service market. And now we also focus on server ecosystems. Mesos is distributed systems kernel for data center OS and the cloud environment. It's a very important project in the server ecosystem. So we're trying to enable and validate the Mesos on ARM servers. And we come here to everybody said servers are not equal to Intel x86 or IBM's PowerPC server. Our ARM is coming, and our ARM is come to this market now. Okay, I will give a brief explanation about why run Mesos on ARch64, and then the next, I will show how to set up a Mesos and the Marathons cluster on ARch64. And at the last, I will show a demo. It's about deploy and scale the containerized applications by Mesos and the Marathon on ARM's cluster. Okay, let's. First, what is ARch64? ARch64 is a 64-bit architecture support to ARM architecture. It was introduced in ARM v8 architecture, which was announced in October 2011. And ARch64 includes as follows as the 64-bit general purpose registers and stack point and program counter, and it also includes the 64-bit data processing and extended virtual addressing. And the last is it includes the 64-bit execution state. And this execution status include exception model, a memory model, and a programmer's model, and instruction set support for that state. So what can we get from the ARch64? There are a new instruction set. It's called A64. And ARch64 is also compatible with ARM v7 architecture, and it also has the same capabilities as in ARM v7 architectures, including like security solutions like trust zone and virtualization. And the more details about what is ARM v8 architecture and ARch64 are in our wiki page, and you can visit this web page for get more information about what is ARch64. Okay, and now ARch64 is also supported by a number of Linux distributions such as Debian, CentOS, Fedora, Ubuntu, and OpenStack. Okay, let's come back to why run Mesos on ARch64. Because our ARM solution benefits are as follows. First is the lower cost. Because the cost of the other chips keep increasing in the last 7 years. And compare with our competitors, our ARM solution is at a lower cost. And the second is the multi-cores and instructions executed in parallel. And not only the multi-cores, Our not only the multi-cores, but also our competitive performance per thread. Our Cortex-A72 has a good performance across all workloads, including integer, memory-intensive, and crypto or floating point, and so forth. At last is the power efficiency. It means the lower power and the more efficient data center will be. As Mesos are distributed system kernels, it provides the resource management and scheduling across the entire data center and the cloud environment. So it can be said that Mesos is at the heart of the data center OS. So it's a good choice to run Mesos on ARM servers for more efficient data centers. Okay, I believe everyone is very familiar with these pictures, and Zookeeper is a centralized service for maintaining the configuration and providing distributed synchronization. And it will elect a leader as a primary master out of some other master nodes for fault tolerance. And the Marathon is a container orchestration platform for Mesos. And the Mesos servers also, we are now called Mesos agent, is a real workhorses. And the org applications include the Docker applications are running on these slave nodes. Okay, let's to show how to set up Mesos and Marathon on ARch64. And first of all, Mesos and Marathon's packages should be built for ARch64 on Ubuntu. Fortunately, it's not big difference between ARM and other platforms. If you are a newcomer to Mesos world, it's easy for you to set up Mesos cluster on ARM. Except that we figure out the following two kinds of problems. It includes one is the Mesos third-party modules for ARch64. They all need to be upgraded to supported ARM. And the other kind of problems is the build issues for glog. And the glog cannot recognize the build platform on ARch64, so we configure a gas file for ARch64. And the next steps are installation and configuration. It's also easy to configure the cluster for ARch64 by following the Mesos and Marathon's official wiki. All service running on cluster are shown at the pictures, and the master and the slaves, the distros is all Ubuntu, and the Mesos master and the Zookeeper and the Marathons was on master, and the master engine service and the Docker daemon and the applications are on Mesos slaves. Okay, if everything is okay, we have built the Mesos and the Marathon packager and do some configurations. And the Mesos and the Marathon will be successfully set up on our ARM cluster. So before the demo, let's look at some picture first. Okay. First, this is our ARM cluster overview in our demo, and everything is running on an ARch64 bare metal machine. And we also have created the 3 ARch64 virtual machines. And the Mesos abstracts the distributed hardware is a single pool of resources, and the Marathons and the Mesos framework deploy and scaled applications, and the Mesos will schedule the resources to each application instance by its own scheduling algorithm. Okay. In the demo, I will deploy and scale the containerized applications. It's about two Django web servers and HA proxies to load and balance. We can access the same web page either on server 1 or server 2 by HA proxy. And all applications are porting to the Docker containers, which can be deployed and the management and the scale by Mesos. Okay, all ARch64 Docker images are pre-built on Mesos slaves respectively, and both on slave 1 and slave 2 in this demo. And we can access these containerized applications via the port, which is dynamically mapped by Mesos and Mesos. And this tool and this web servers support it. And we actually, to visit this web page by port is mapping by Mesos and Mesos. Okay, the next I will show some how to build the ARch64 Docker images and some customized, initialized the scripts. It's the Django Docker file, and this is the initialized scripts. It's configure the Django and copy some configuration file and state files, increase some pictures and the HTML file. And the last we will start a server. Okay, this is the Docker file for HA proxies, and this is the customized initialized scripts. We configured the backends by these two environments support for to load balance and okay. Okay, and the next I will show a demo. It's about sorry. Okay, we have connected our ARM servers with SSH. These servers as a bare metal machines is in our Shanghai lab. It's ARch64, and the distro is the ERP, which is released by Linaro. It is based on CentOS 7, and we have created the 3 virtual machines on this bare metal. So, okay. Wait a minute. Okay, this is virtual machines management UI, and we have created 3 ARM servers. Virtual machines Mesos slave 1 and slave 2. This is 3, and okay. At the distro, this virtual machine's distro is Ubuntu, and the architecture is ARch64. And the first I will to start the zookeeper, and to start Mesos master. Okay. I'll find its Mesos master daemon is running, and let's visit the Mesos UI byte port 5050, and okay, it's running, and there's no agent. So let's start the engine. Okay, we'll find there's two entities is available for the users, and okay, it's the Mesos is running on our ARC64, and the next I will to start the marathons. Okay, here we'll let's wait a moment. Sorry. The Mesos UI is sorry. It's the port 8080. Okay, the Mesos is successful running on our clusters. We have pre-built the Docker images on Docker slaves respectively. Sorry. Okay, this is for Django server, and it is for HA proxies. Also, slave 2. So let's create a Django web server by Marathon first. ID is ARM web server. Oh, sorry. And the Docker image is the Django ARC64, and the host is bridged, and the ports is the server ports. The default port is 12580, which is pre-configured in the Docker file. But we can modify this port to any port by set the environment variables. So we can set 1, 2, 3, 4, 5, and the environment. Okay, the ports. Let's check it. That's great. Wait a minute. Oh, it's running. Okay, we can find the Mesos and Marathons deploy these applications, the web applications on slave 2. Let's visit these web pages. Okay, it's the web pages where it's running on slave 2, and this is our lab server snapshot, and it's our office in Shanghai. It's the web page, we can check it. There's the active the task in Mesos UI we can find, and in the slave 2 we can find it. The container port is 12345, and the Mesos dynamic mapped this port to 31885. So let's scale these applications. 1, 2, 3, okay. Okay, there's 2 servers running on slave 1 and 2 on slave 2. We can also visit, sorry. Okay, so this is the web page is running on slave 1, and another thing is the same. Okay, the next step will to deploy HA proxies in Docker, and for load and balance to web page access. The Docker file is HA proxies ARch64. Load and balance, and the container is the host. The network mode also is bridged, and the container port is the listening port for HA proxies. The default port is 8A, and we set 2 environments for backend, for HA proxies backend. The first is sub 1 port, and the 2 is sub 2 port. So, and we use these servers 1 and this server 2 for backend for load and balance. So slave 1's port is this one. And slave 2 port is this one. Okay, let's check it. The 31885 and the 31895. Okay, it's great. Delay and wait a minute. Okay, it's running. It's the Mesos also deployed this HA proxies. Slave 1, we can also let's shoot. Okay, we can visit this web pages on slave 1, and we can refresh this page. It can be load and balanced to visit to slave 1 and also to 1, 2. So, and in the Mesos UI, we deploy the 5 applications. It's the 4 is for web server. The other one is for load and balance. It's HA proxy. So these clusters and containerized applications is running on ARch64 server. It's a real server on our lab. Let's begin sorry, okay. So that's all for the demo, and the future work we will, first work is we enable and validate the Mesos marathons ARM servers, and the next we will do some profiling work and do some optimizations that compare with the Mesos performance running both on like ARM or like on Intel's x86 or like Power. So, and that's all for this presentation. And any questions? And 中文也可以。哎，你好，你好。
我想问一下，这个演讲书主要的就是在这 ARC64和正常那个x86 server 的区别？主要它是省电，还有这些省资源。
对，我们主要是因为我们主要的工作是除了就是我们 ARM 推出，现在加入就是进军 ARM server， 然后呢，我们的主要工作是对 server 的 ecosystem 进行一些完善。所以 Mesos 作为一个重要的环节，所以我们要首先做一个 enablement and validate 在 ARM 上能跑。然后呢，我们下一步会做一些优化的一些事情。那对比x86，我们也我们在我们的 lab 里边也有一些x86的服务器。然后呢，这个问题呢，就是说，因为我们 ARM 的整个生态目前为止，从 JDK， 从 compiler， 从一些工具，还有从 distro 支持的都比较完善，就是逐步，因为我们也做了2年，就是从底层工具开始。所以说，在编 Mesos 的时候，我们只是碰到一些可能依赖包的问题，可能第三方库它不支持 ARM， 它可能遇到一些 native 的一些包，我们做一些升级。然后真正的就是关于编译器、关于 JDK 的这些 bug 我们修的比较多，所以在编译、在跑、在编译 Mesos 的马拉松是 Scala 的吗？还是这样说？所以说碰到的问题不是特别的多，所以。
那这个是不是这个可能是只有自建机房的那些可能才会需要这个。
自建机房，你说的自建机房我们是这样的，就是如果大家就是开发者一起进来的话，我们下一步在和 Linaro 做合作的，就是我们会买很多服务器。现在我们的合作伙伴，包括 Qualcomm， 包括 HiSilicon， 包括 Kevin。还包括包括 MD 这些，然后呢，我像他们现在做一些采购，就是采购完之后，我们会跟 Linaro 合作，做一个类似于 Dev Cloud， 给你一个云的，给你一个虚拟机，或者给你这个东西，你可以在上面做你的工作，就是做一些 ARM server 的一些工作。其次，
其实现在，
然后你说自有机房是什么意思？就是
因为现在大家都用公有云嘛，像阿里云、AWS， 其实。直接买那些虚机就都能跑了，但是如果
对我们现在就是公有云的，现在因为阿里和腾讯他们都用，腾讯用偏 Power 多一点，然后阿里还是一些互联网厂商，大家用的都是x86比较多一点。我们现在因为每年会发布一个 Linaro 的一个 ERP， 就是在 ARM 上 server 上跑的一个标准的一个 distro， 包括 Debian， 包括 CentOS， 然后我们也在跟阿里产生一些合作。就是如果大家到他们那边去，他们提需求，我们给他做一些东西，然后逐步阿里可能会用一些我们 ARM 的 servers， 就是现在这个工作模式跟以前我们在 mobile 市场大家一块板子一起玩完之后一起想做 contribution 有可能有稍微不一样，因为我们的 ARM 的东西是一个标准，服务器是个标准化的东西，所以我们可能就偏跟企业之间的合作，主要是这样。
谢谢。
Okay.
Thank you. I have 2 questions. One first is related to the cost. Like, how much is the cost difference as compared to the other vendors like HP or Dell? As if you compare them with the ARM.
Sorry. And how many what?
I mean the cost difference. You said like it's going to be cheaper than compared to the other.
And you mean difference between
price?
Price.
Yeah.
Price, you know, our company is an IP company, so our, you know, to some loyalty and the license to our partners like HiSilicon, Qualcomm, and they manufacture the real server. I mean, it's real cheap and manufacture. But our loyalty and the license cost is lower, and the same day can manufacture servers. The price is lower than Intel, and you know.
And from the specification perspective, is it kind of going to be the same kind of the blade server?
Play server.
Like the HP blade server and all, like the Dell?
Oh, DH.
Like how is going to be look like in actual?
It's going to take many forms.
Sorry?
Yes, actually, there's a picture.
What? Sorry.
So the servers are going to take different formats. There's blade servers, there's standard pizza boxes, 1U, 2U, 4U, half width, full width. It really is a huge choice. One of the advantages of using the ARM servers is that from currently you're tied to a single vendor when it comes to your CPU most of the time. It's Intel or IBM. So with ARM, you can run your software stack on the ARM architecture, but have a choice of Qualcomm, Cavium, HiSilicon, HXT, Marvell, whatever. You can mix your data center, you can change every 3 years if you wish, it's up to you, and your software will still work. So you don't have to worry about, we need to port again. It's port once and run anywhere. The TCO aspect is also of benefit because we can have much more dense servers. So first generation, you can have 96 cores with a terabyte of RAM in 1U. So you scale that up to 30U, and you're still going to be drawing half the amount of power versus 12U of
The price. Okay, the price.
well, the competition. So overall, your cost will come down, as well as the initial cost. So that there are multiple choices of how you can go about that.
Okay. Any questions? Okay. Thank you very much for listening, and that's all. And